Hello, my name is Larissa, and this video discusses the chemical formula. The chemical formula indicates the relative number of atoms of each element in a chemical compound. The chemical formula allows a consistent way of referring to different chemical compounds. There are different types of compound. A molecular compound the chemical formula refers to the number of atoms of each element in a single molecule of the compound. In an ionic compound, the chemical formula refers to a lattice of positive and negative ions held together by mutual attraction, and the simplest ratio of these cations to anions. So for me to simplify that, positive and negative ions held into a lattice configuration by mutual attraction. The ionic compound is the simplest ratio of ions. So an example of this is aluminum sulfate. The subscript 2 here means that there are 2 aluminum atoms. The 3 here, outside the parentheses to the right, refers to how many of this combination inside the parentheses there are in the ratio to the aluminum. So, in this case, there are 3 sulfate ions for every aluminum ion, sulfate being SO4. The 4 here, subscript, means that in every sulfate ion there are 4 oxygen atoms. So, in this particular molecule, there are 2 aluminum, 3 sulfur, and 12 oxygen, because there are 3 sulfate times 4 oxygen needed. So, 12. An example of a molecular compound is a hydrocarbon. Because hydrocarbons consist only of carbon and hydrogen atoms. And these are bonded together covalently. For example, C4H10. Also known as butane. Another important concept are monatomic ions. Monatomic ions. Mono meaning one, and atomic meaning atom, ion meaning having a charge. It means a charged atom formed by loss or gain of electrons. These monatomic ions usually lose or gain their electrons to form a noble gas configuration. So an example of a monatomic ion is sodium ion. Group 1 elements usually just lose one electron to form a +1 ion, a +1 charge, a cation, meaning positive charge. And group 2, for example magnesium, lose 2 electrons forming a cation. Nonmetals, such as elements in groups 15 to 17, tend to gain electrons to form an anion to complete their outermost octet. So they want that full electron configuration. An example of that are oxygen 2-, so they start out with 6 electrons in the outer shell and they gain 2 so that it becomes 8, and that's a full valence shell. And also fluorine 1-, so fluorine minus. Not all monatomic ions form valence shell configurations. For example, group 14 elements, tin and lead, lose 2 electrons instead of 4 because it takes less energy to bring about this, and it's stabler because they're losing their p orbital. But the s orbital is maintained. Another exception are, not really an exception, but d block elements have their own special behaviors, and they can form 1 to 4 plus cations, some having multiple potential cations. So some elements can form more than one different ion. Example, abbreviated V, can have a 2 plus, 3 plus, and 4 plus possible charge for its monatomic ion. And some elements don't even form ions. For example, carbon and sulfur just covalently bond. They don't form ions.